Hello, it's time to start. My name is Byungchul, and I'm working at SK hynix. I'm here to introduce DEPT tool for deadlock detection. I'm going to talk about the two tools. One is Lockdep, and the other is the tool, Lockdep, that I'm developing. Okay, imagine code like this. These two contexts need to acquire two spin lock A and B, but the acquisition orders are different. As already you know, it's a typical A-B-B-A deadlock. With a simple code like this, it's not hard to track deadlock conditions, but with code using complex synchronization mechanism, it's very difficult to track deadlock condition solely using one's brain, right? So we need checker tool to check lock orders. And of course, it would be much better the check is done before a deadlock actually happens. And in this presentation, I'm going to talk about runtime checker, meaning there are hook functions in all the synchronization mechanisms and play the roles of the checking and reporting. The first tool I'd like to introduce is Lockdep, developed by Ingo. Lockdep defines dependency this way. When acquiring lock A and then lock B while holding A, it indicates that A depends on B. So in this example that I showed you earlier, by the definition, context X has A to B dependency, and that can be added to a graph data structure in global space. And similarly, context Y has B to A dependency that can be added to the graph. By using graph algorithm, a cycle can be detected. Circular dependency means deadlock condition, so the tool can report it as a problem. In other words, deadlock condition, like this, right? A system might have a dependency graph like this. Once YQ dependency is added, the tool can detect the cycle and report it as a problem. Let's look at more complex example. Before going ahead, I'd like to remind you of dependency definition by Lockdep. Two consecutive lock acquisitions are required to create a dependency. So in this example, only context Y has two consecutive lock acquisitions. So only C to A dependency exists in this example, and it can be added to the graph. Since there's no cycle, so the tool wouldn't report anything. But these three contexts are stuck at these highlighted points. As you might know, to awaken wafer event B in X, event B in Z must be triggered, but that can happen if mutex lock C is successfully acquired. For mutex lock C to be acquired, mutex unlock C in Y must be executed, but that can only happen if mutex lock A is successfully acquired. For mutex lock A to be acquired, mutex unlock A in X must be executed, but it can happen if wafer event B is awakened. So all of these contexts are waiting for the events that will never happen. We call this deadlock. So not only locks, but also any waits can cause a deadlock. So it's very important to consider general waits when checking deadlock condition. The second tool I'd like to introduce is that I've been developing. Let's look at context part. To trigger event A, wait B must be awakened. For wait B to be awakened, event B that wait B is waiting for must be triggered. By deductive reasoning, we can conclude that to trigger event A, event B must be triggered. So instead of the previous definition, I'm going to use this definition in depth. So when event A occurrence depends on event B occurrence, I would say A depends on B. This is the example I showed you earlier. I will change comments to reflect the perspective of DEPT, but keep the original code unchanged. Spin lock is a wait for the interesting spin lock to be released, right? And spin unlock is an event to its wait. So in this case, by the new definition, since spin unlock A is not reachable unless the spin lock B is waiting for is triggered. So we can say A to B dependency exists and can be added into the graph. And similarly, context Y has B to A dependency by the new definition. You remember? That dependency can be added to the graph by using a graph algorithm. A cycle can be detected and the tool can report it as a problem. This is the example I showed you earlier, more complex example, where Lockdep couldn't detect the deadlock condition. Let's see if DEPT can detect deadlock conditions that exist in this example. I will change the comment similarly to reflect the perspective of DEPT, and similarly leave the original code unchanged. Okay. Context X has A to B dependencies by the new definition that can be added into the graph. Context Y also has C to A dependency that can be added to the graph. Context G has B to C dependency that can be added to the graph. So by using a graph algorithm, a circular cycle can be detected, and that can be reported as a problem. The dependency graph that I showed you earlier can be expanded thanks to the additional dependencies that comes from general weights, allowing DEPT to work better with the richer dependencies. So once N2G dependency is added, the tool can detect the cycle that should have been visible but was not. Okay, this is about how wait and event work. When it comes to wait and event, to ensure event A, that event wait A is waiting for, is triggered before putting context to wait state. This context must request to start event context toward event A. And between start point and event, there might be some weights that prevent event A from being reachable. Okay, in this case, it's weight B. DEPT labels them as WE in its report. And in the diagram I showed you earlier, SWE can be labeled this way. By understanding what the labels means, you can interpret depth reports better. So, okay, now that you have a brief understanding of how depth works, let's see what depth can do in practice. This is an email from LKML mailing list. Japanese developers reported and addressed deadlock issues between pglock and nilock in NTFS 3. Since pglock behaves more like general weights rather than typical locking mechanism, unfortunately, this issue cannot be detected by Lockdep. Linus Torvalds asked me if DEPT can detect the deadlock condition, so I checked it and replied with a captured report to him. The highlighted code passages are one we are interested in for this issue. This is the reply to him. Why? Okay. This is.
The reply was also highlighted like this.
Sorry?
It was also highlighted like this. Otherwise, it's hard to read.
Okay, let me continue. DEPT successfully captured the problematic call stacks for this issue, as I expected. Okay, this is another email from LKML mailing list. In this case, Igalia developers reported and addressed a deadlock issues involving folio lock and a mutex. Since folio lock also use pglock flag internally, so once again, this issue cannot be detected by Lockdep. So in this case, Andrew Merton, who is a memory management services maintainer, asked me if that can detect the deadlock conditions. So I asked the Igalia developer to capture the deadlock report by DEPT, if possible. Thankfully, he replied with a captured report. This is the highlighted core passages are ones we are interested in for this issue. Okay, it's his reply. In this case, DEPT also successfully captured the problematic core stacks for these issues. I think it was cool. Okay, this is not about track weight and event, but it's about correctly handling nested lock. But I will skip the details because they are not crucial to DEPT main goals. Okay, let me summarize. Oh, by the way, my speech is too fast? No? Okay. Let me summarize benefits of DEPT. Firstly, DEPT works on general weights additional to typical lock mechanisms. As I mentioned, folio lock behaves more like general weights. So that can be considered by DEPT that exactly track general weights. And DEPT also supports wafer complete and various types of weights like TMA fence or something. Okay. Secondly, with that we can annotate weights and events simple way. Honestly, this is more for advanced user, since all the existing synchronization mechanism has appropriate annotations that I added. However, if you create a new synchronization mechanism or want to annotate weight and events at a conceptual layer, you would find this annotation API useful and simple. Thirdly, DEPT tracks read-write locks simple way. Okay, I will give you 5 seconds. Which one is false? 5, 3, 5 or 4, 3, 2, 1. Okay. Since read critical sections can be executed simultaneously, multiple read critical section can be executed simultaneously. So read lock doesn't have to wait for other read critical section to end, right? So the first statement is false. So okay, let's see how DEPT deal with this read write lock. Okay, this is read lock case. For mutex unlock B to be reachable, read lock B must be awakened if it's in a lock contention. And the only event that can awaken read lock B is write unlock B. So I'm not sure if you still remember the new definition of a dependency. By the definition, A to B dependency exists, and they can be added to the graph like this. Okay. Let's examine write lock case. Similarly, for mutex unlock A to be reachable, write lock B must be awakened. If it's in a lock contention, the events that can awaken write lock is either read unlock or write unlock. So in this case, it has 2 dependencies: A to read unlock B, A to write unlock B. So the dependency graph must look like this. All of these weights and events after all. So by tracking weights and events, all the cases can be covered, including typical lock mechanisms and read-write locks and general weights and so on. The last benefit is that DEPT is resistant to false positives. Honestly, this is about multi-report support. Multi-report support, yeah. If you are familiar with Lockdep, as you already know, Lockdep stops reporting on the first report. And true ones can be suppressed by false ones. To see true ones, it's required to fix them one by one, right? So false positives must not be allowed in Lockdep. But DEPT doesn't stop reporting unless resources, for example, memory, run out. DEPT keeps reporting further ones. Of course, first ones should be removed anyway, though, but it makes false positives less harmful. Let me conclude. If you are fine to miss some reports, but want less false positives, because as you already know, as for Lockdep, the effort to remove false positives has been done for about 20 years, so there are less false positives, about typical lock mechanisms. But as for general ways, never was done before. So once using DEPT, you can see many false positives from that. So in this case, Lockdep is the best option for you. But if you're eager for any hints of deadlocks with complex code, I think the perfect tool for you is DEPT. This is what I want to say. Okay, I think I was faster than I thought. This is the. I added appendix, but I will not talk about the appendix today. Okay, that's it. Okay, that's it. John Corbett.
So this work has been around for a few years now, and there's been quite a bit of resistance to upstreaming it. How would you describe?
I'm sorry, but can you speak slow because
Sorry. This work has been around for some years, and there seems to be a fair amount of resistance to upstreaming it.
because of false positives.
So you think false positives are the real problem, keeping it from the main line?
As you might know, when Lockdep was introduced, there were many false positives, but all of us pay effort to remove the false positives. So I think at the beginning, I think we cannot avoid the false positives that from. So I don't think it's a quite big problem to be merged into mainline. What did I say? I don't think it's not I don't think it's a problem.
Okay.
Yeah, my question goes in the same direction. So you were already asked for help from two well-known maintainers if you could look at a specific problem, and you could, and reported them valuable information back. So I'm a little bit surprised that it's stuck now. And then
I'm sorry, too fast.
Too fast?
Yeah.
It goes in the same direction. So we were asked already 2 times by well-known maintainers for help to look at specific problems, and you were able to report back valuable information. So I'm surprised that it is actually stuck in moving forward into the kernel, because it provides additional helpful information while debugging. So, but on the other hand, thanks a lot for keeping working on that. And the second question, because we had really hard fun in the recent past with read Deadlocks on preempt or T-enabled kernel. Have you just tried running that on a plain real-time kernel, real-time enabled kernel, and what was the result? So complete explosion, or?
Of course, I have a plan to learn that on preempt RT, but before answering that, at the moment, currently, that rely on Lockdep compete. So, but first try was to apply Lockdep to preempt RT, and I saw what's gonna happen. But even with Lockdep applied, it almost doesn't work because there were many. Looks like there were many problems with preempt RT and Lockdep. No.
No, it works fine usually.
It works fine.
Yeah.
Works fine.
From my experience, it works fine.
I mean, there were warnings or issues that had to be solved, but in general, it works.
Okay, let me ask more. A friend of mine tried that, and he told me there are a lot of issues. So I think I need to check that. Okay. Then I think if you are right, then sure, I immediately apply that to a friend party and want to see what's going on.
That would be cool.
I believe there will be many valuable reports. Yeah.
So you, or I personally would be very interested in that, so if you need help, we
Oh,
can bring them.
sure.
Yeah, so one of the bigger issues we have with Lockdep is that it's a kernel, it's a build time option that needs to be enabled. So if you see a problem in the field and have no easy reproducer in your lab, then you're stuck because you can't enable Lockdep in the field without shipping a new custom built kernel there. Would there be an option to implement this approach using eBPF so that you don't need to replace the kernel in the field?
Are you suggesting why don't you use the DPF
To get the events.
But if they weren't enabled when the deadlock occurred, you won't have them.
What do you mean?
If the debug was not enabled when the deadlock has occurred,
Yes.
and you enable it after that, you won't have the events.
Yeah, but I mean, you could enable it with a reboot, but without a recompile.
Yeah, but that means that you need to reproduce the problem after. the
Yeah, at least
deadlock.
once, for sure.
Yeah, of course, but I mean, anyways, you have to traverse the code path there at least once, otherwise it's invisible to the detector. But my question is really,
Yeah,
is there an option, or might it be possible to enable this feature at runtime, maybe with a reboot, but without building a custom kernel with that option enabled?
so let's say at boot time, not at
Yes,
runtime.
yes, exactly,
Boot
at
time.
boot time.
Yeah, I think that kind of approach might be very useful. For similar purpose, I'm thinking to make it work as a module. But similar approach is required even for that work. But using eDPF is also, I will think about it. Thank you. And if you have any feedback in future,
I will let you
be
know.
appreciated if you,
Yeah, but thanks for the great work.
thank you.
Right. So I've seen like some of the maintainers, file system maintainers that complain about false positives, but I don't see a reason why the fact that DEPT produces false positive shouldn't refrain from merging the code. It should refrain some maintainers that don't want it from using it, right? If you merge the code and there's no, I don't know, extra maintenance complexity or anything, if you have 2 maintainers that want the code and 40 maintainers that don't want to use it, then there's all the reason to merge it and have the ones that do want it enable it. So what's really the problem with merging the code and default disable? Is there a problem with that? Did you get a pushback from, I don't know, from Linus about merging your code with default disable?
Simple sentence, can you ask me again?
Yeah. The question is this. Did you ask Linus if he can merge your code with default dept? No, disabled. Because I have like 3 maintainers that want to run this code.
I want to.
Is there a reason for him not to merge this?
Yeah, I asked 2 times to principal both.
Yeah.
Of course, I want to disable by default,
Yeah.
and even marked as experimental.
Yeah.
Yeah, but yeah. The first time he answered, I think, let's look at what that can do more. At the second try, he didn't answer.
No, but okay. Follow-up question: who is the maintainer that will suffer the most from merging your code because it has overlay?
EFT4 maintainer
Huh?
has so. Who? EFT4 maintainer has so.
Yeah.
Yeah.
No, he's just complaining about he doesn't want this. No, he doesn't want to use the tool. That is fine, but there's no burden on him. If the code is merged, there's no burden on him. Like Igno, there's burden on him if you merge your code because it's more complexity, right? On the schedule.
I also like a code more complex, but I don't.
The question is, yeah, you need to go to the maintainer like Igno, who is going to suffer from Linux merging your code and say, do you have objections? If you have objections, maybe I can address them. If you don't have objections, let's go forward.
Okay, good. I think a good advice to our thinking to do that as you suggested.
I mean, yeah, if somebody complains that he doesn't want to use the tool, it's fine. Don't use the tool. Doesn't matter.
Thank you for
Actually, no one else uses Lockdep in production, right?
Well, it doesn't matter. We use it for development. It's important.
Yeah.
Yeah.
Who doesn't want it, don't turn it on.
Yeah.
always developers ask me to use that in their work, like especially like a GPU driver, where that has their own synchronization mechanism, like a DMA or something. Yeah, so I already know there are some developers who want to use this one. Yeah, I'm gonna keep working on it then, until I make it.
I think third time is the charm.
Okay, is there any question? Because I finished earlier than when I supposed to do, so I can talk more.
Maybe a last more technical question. So how is it technically structured? Is it more let's say, an improvement of Lockdep, or is it something that's to some degree relies on Lockdep infrastructure-wise, or is it completely separated?
One more time, please.
It's more about the code structure, let's say. Is it an improvement to Lockdep, organized as an improvement to Lockdep, so you're basically reusing a lot of the infrastructure that is already there? Or is it more something like a complete addition?
I'm not sure if you ever heard the cross-release feature. Is it first time? I have tried the cross-release feature that was working on top of Lockdep. So the feature, of course, we use Lockdep code, and it's already got merged into mainline, and then liberty, because of some guys is complaining for false positives. Yeah, so I thought at the time, by the way, I cannot achieve fully what I want to do with cross-release feature. Rather than we use Lockdep and add the additional feature like the cross-release doesn't. If you don't mind, can you talk about later or email? Yeah. Any other question? Oh.
Can I reuse this code for user space and other project also? Or is it very tight Linux?
Yeah, I think there are many requirements like that. The user space want to use kind of this mechanism. I think it's possible.
I'm afraid that you will need access to the scheduler because the conditional waiting is...
Yeah, but-
The event waiting is conditional variable which you can check
Yes.
tasks are switched, so I'm not sure how that would be implemented.
Yes, that's what I need to implement anyway. I need to implement it on POSIX, but the Lockdep algorithm itself could be reused, I guess. The graph and
Yeah. What I would like to say is that I don't see a reason that it should not be reusable, but that's the thing I don't know how it will be implemented.
okay, yeah.
But the question would be why? Because you have Kisan with lock detection as well, and that tool works quite well because it just is based on if they happened before relation.
That covers this use case.
Yes.
Okay.
So at least
Without
the use cases
detection.
he showed there are.
Circular walks through wait conditional.
Yes, it should. I mean, it needs to be.
I think it needs to be also
Almost
there,
so.
right? You,
Yes, but I mean, as long as you use POSIX
yeah.
synchronization infrastructure, then or methods, then it should be aware.
Yeah, so you're suggesting reusing TSUM instead of this.
So I often use it in user space code, and the results are really good. And I mean, if you have a custom synchronization, you can annotate it. So
Which one is that?
thread sanitizer minus f sanitize thread.
Any other question? 3, 2, 1. Thank you.